Find the derivative and simplify. Here in this first example, we've got y equals the cube root of x plus sine of 3x squared. Now this square here only affects the 3x. If I wanted to say that this square affected a sine instead of that 3x, I would have written sine squared of 3x. So please know the difference between that. So the first step that I want to do here is to get rid of this radical sign. I want to rewrite this as y equals x to the 1/3 power plus sine of 3x squared. And now I want to find the derivative. So the derivative will be y prime equals 1/3 x to the negative 2/3 power by the power rule. And in the second term over here, there's a sine on the outside and a 3x squared on the inside. So this will be plus, with the chain rule, you take the derivative of the outside function and leave the inside function alone. So that'll be 3x the quantity squared. And then you multiply that by the derivative of the inside function, 3x the quantity squared. From here, the derivative of 3x the quantity squared, let me finish writing the rest of the derivative here first. Negative 2/3 plus, we have that cosine of 3x the quantity squared. The derivative of 3x squared here requires another chain rule. So we will take the derivative of the square to the front, leave the inside alone. So that'll be times 2 times 3x. Then we have to take the derivative of the inside and multiply it out back. So the derivative of 3x is 3. So all of this last part here is 2 times 3 times 3 is 18 x's. I'm going to move all of that in front of the cosine, just to make it look nice. So we've got y prime equals 1/3 x to the negative 2/3 power plus 18x cosine 3x the quantity squared. There's the derivative for the first example. In the second example, there will be something similar. We will have a chain rule. You can see here there's an inside function, the 2x minus 5, and an outside function cubed. And we're multiplying that times x. So we're going to have to use the product rule first. So we will separate these problems here as so. And what we do here is the first, I'm going to call that x, I'm going to do that in white, and the second here in red. So we will have f prime of x be equal to the first times the derivative of the second. Now this is going to require a chain rule, as mentioned already. We will take the derivative of the outside, this power 3, 3 times 2x minus 5 squared times the derivative of the inside, which is 2. To that, I'm going to add 2x minus 5 to the 3rd power times the derivative of x, the first, which is 1. So now to simplify this, the only simplifications that need to happen are a common factor, if there is one, and multiplication of any constants. Like here in this first term, there's a 2 being multiplied out back and a 3 being multiplied out front. So we need to multiply those together and get the f prime of x equaling 2 times 3 times x is 6x times 2x minus 5 squared plus 2x minus 5 cubed. The only thing I can do from here is factor out a 2x minus 5 squared. So this will equal 2x minus 5 squared times 6x plus 2x minus 5. Oh shoot, so since we common factored out this 2x minus 5 squared, I've got now this set of parentheses here with a 2x plus a 6x, and it's best to simplify that as well. 8x minus 5. So here is your simplified answer for that function. For these two examples, again, we need to find the derivative and simplify these. I'm going to first divide the page in two parts. There we go. So now I can say y prime equals, this one is going to require us using the quotient rule. So I'm going to use red for the top, and I will use blue for the bottom. And before I go any further, I want to rewrite this as x squared plus 1 to the 1/2 power. That way when we start finding the derivative of this, it'll be much easier. So alright, the quotient rule states you start with the denominator, so that x squared plus 1 to the 1/2 power, times the derivative of the numerator, which is 1, plus the numerator, x, times the derivative of the denominator. Using the chain rule, this will be 1 over 2 x squared plus 1 to the 1/2 power, all in the denominator, times 2x. So that was moving the exponent 1/2 out front and subtracting 1. 1/2 minus 1 is negative 1/2, which is why this is in the denominator. You push it down and it becomes positive 1/2. Then the derivative of the inside part is 2x. So all of this is over the denominator squared. So x squared plus 1 to the 1/2 power squared. And that's a lot of information, and it is not simplified at all. One thing that we need to get rid of is this fraction within a fraction. So in addition to the common factors and the multiplying constants, we also need to make sure that you don't have any complex fractions. So the best way to do this is to multiply top and bottom by whatever this denominator is right here. I suppose before we do that, we could simplify this 2 and this 2, just to make it a little bit easier. So I'm going to rewrite this like so, and I'm going to multiply the numerator, the big fraction here, by x squared plus 1 to the 1/2 power, and the denominator by x squared plus 1 to the 1/2 power. Now, when I multiply the numerators together, this is in a giant set of parentheses, and this needs to be distributed to each term. And the whole point for doing that is to make this denominator disappear. And I realize now that the quotient rule should be having a subtraction in between the two terms. So right here, this should be a subtraction, and right here, this should also be a subtraction. All right. So when you distribute this out and multiply the denominators together, you'll get something that looks like this. So when you distribute the x squared plus 1 to the 1/2 power to the first term, you're squaring this exact thing, or raising it to the second power. And if you raise something to the 1/2 power to the second power, you multiply the exponents together and you get an exponent of 1. Now we do not write that, but it is there. So then In the second term in the numerator, when you multiply this here, the denominators cancel. We've already talked about that. But here we have in the denominator x squared plus 1 to the 1/2 power. We have two of them being multiplied. If you throw a third one in there, it becomes the third power down here. So the final steps here are to reduce these away, right? X squared minus x squared is 0. And then multiply these two exponents together. So your final answer will be 1 over x squared plus 1 to the 3/2 power. In the next example, there is going to be a chain rule, and while we do the chain rule, we will end up also performing a quotient rule here. So f prime of x, and I'll show you here with the inside function being red and the outside function being blue. So we take the derivative of the outside function, which is 3, leave the inside alone, square. So what's inside is 1 minus 2x all over 1 plus x. And to that we multiply the derivative of 1 minus 2x over 1 plus x. All right. So I'm just going to go through and figure this out really quickly in its own little scratch world over here. So the derivative of this is the denominator, 1 plus x, times the derivative of the numerator, which is -2, minus the numerator, which is 1 minus 2x, times the derivative of the denominator, which is 1, all over the denominator squared. So that is 1 plus x squared. And when you do all of the distributions and simplification of the numerator, you'll get something like this. -3 over 1 plus x, the quantity squared. So what I'm going to do now is replace this derivative with this expression. So that will give me a derivative that looks like this. F prime of x equals 3 times 1 minus 2x over 1 plus x, the quantity squared, times -3 over 1 plus x, the quantity squared. From here, remember one of the simplification rules is to multiply your constants together. So I've got 3 times -3. That gives me a -9. So I'm going to say this is equal to -9. And in the numerator, I can see that I have 1 minus 2x, the quantity squared. So I'm going to write that in the numerator, 1 minus 2x, the quantity squared. And in the denominator, I've got 1 plus x squared times another 1 plus x squared. That means I have 1 plus x to the 4th power. And that's it. We cannot simplify this anymore. There's your answer for the derivative of this function that we started with. For these derivatives, we will now start making this foray into the trig world. And in this first derivative, it looks like that you may have to do the quotient rule twice. 5x times secant x plus x times tangent x. This is a quotient product rule, and this is a product rule. However, if your factoring skills are up to snuff, then you can see that another way to write this function is x times 5 secant x plus tangent x. So instead of having to do 2 product rules, we can now just perform 1 product rule. So I will get this started here. F prime of x equals the first, which is x, times the derivative of the second, which is 5 times secant x tangent x plus secant squared x So the first term is on the first line there. The second term plus the second 5 secant x plus tangent x times the derivative of the first, which is just 1. So when this all gets multiplied out, let's see, this will be f prime of x equals 5x secant x tangent x plus secant squared x plus 5 secant x plus tangent x. So this entire piece here is the entire derivative. It continues to the next line. And it doesn't look like we can pull anything out of all 4 terms. So this will be your final answer here. In this second example, over here on the right, we have the function 7 times cosine cubed of pi x plus 2. I want to rewrite this so you understand what this cube means. So this is the same thing as f of x equals 7 times cosine of pi x plus 2, the entire thing cubed. So now there's an inside function and there is an outside function. So this will use chain rule. Chain rule starts with the outside function. So this will be f prime of x equals 7 comes along for the ride. The outside function is the power 3, so I will bring down that 3, leave the inside function alone, take 1 away from the power, and then I will write in the inside function here, pi x plus 2. Then we take the derivative of the inside function, cosine of pi x plus 2. And here, this creates another chain rule when we take this derivative. We have cosine being the outside function now, and the pi x plus 2 being the inside function. So I've got this, f prime of x equals, I'm going to multiply these two numbers together here and get 21 times cosine of pi x plus 2, the entire thing squared. And to that we will multiply the derivative of cosine pi x plus 2. First, the outside function, we're going to multiply negative sine and leave the inside alone. And then we will multiply by the derivative of the inside, which is pi x plus 2. The derivative of that is just pi. So now we have to collect any constants. It looks like we're only going to be simplifying with constants here. 21 times pi is 21 pi, times the negative 1 in front of the sign is negative 21 pi. So this derivative, f prime of x, equals negative 21 pi, and then we'll have the cosine of pi x plus 2, the entire thing squared times sine of pi x plus 2. And this is your derivative for the second example. The last derivative here, we want to find the second derivative of this function right here. Now, anytime you see one term in the denominator, you want to jump for joy, you want to set off all sorts of bells and whistles, because this function can be simplified, and rather nicely, to help you get through this derivative much, much easier. Otherwise, if you're comfortable with using the quotient rule twice and simplifying twice, please go ahead and do that. I will not do that. I am going to choose to split it apart. So this will be x squared plus 2x over x minus 1 over x. And when you simplify all this down, you get x plus 2 minus 1 over x. So I'm going to use this function to take the derivative. So when I find f prime of x, I know that x will turn into 1. The derivative of a constant, this 2, is 0. And this portion of the function is the same thing as writing x to the negative 1 power. So I know that that will turn into negative x to the negative 2 power. And I'm not even going to rewrite this so that this goes down to the denominator, because I'm not stopping at the first derivative. I need to go all the way until the second derivative. And if you push this down to the denominator, you'll just have to bring it right back up to the negative 2 power, so you can use the power rule again. So the second derivative of this, the derivative of 1 is 0, and the derivative of negative x to the negative 2 power is positive 2x to the negative 3 power, which can be rewritten as 2 over x cubed. So here is your second derivative for this original function.